we're going to look at covalent substances. We've looked at metallic and ionic substances in previous lessons, so we're going to deal with this slightly more difficult, but not much more difficult, concept of covalent substances. And this, you may be wondering what this is, or you may know, which is dry ice, which is carbon dioxide, which we know is a covalent substance, and it's in solid form. Okay, so we're going to look at what these substances are like. Okay, covalent molecular substances are first. There are two types, and this is one of them. So covalent molecular substances are chemicals in which the component atoms are bonded with covalent bonds, which makes sense. A covalent something substance is covalently bonded. That makes sense. But I just mentioned that there are two of them, the covalent molecular one and the covalent network one. So what is the difference? Well, a covalent molecular substance exists as discrete groups of atoms called molecules. For instance, in an ionic bond, an ionic substance, so each charge is surrounded by 6 oppositely charged ions, and then each of those charges is surrounded by another 6, and so on up until infinity, or till it ends. So there's no sense of discreteness. Each part is one small section of the whole. Each one interacts with the whole. Whereas a covalent molecular substance doesn't have that structure. If I had, say, 6 atoms, then they would exist maybe like this, as groups of 2. So each of these group of 2 is completely independent of the other 2 groups. And that's what a molecular substance is like. While in the ionic substance, 6 of them are all smooshed together and they're all interacting very heavily. These 6 exist as 3 groups which are happy to move independently of one another. And that's what we call a molecule. Each of these is one molecule. And because they are all discrete and act independently, then we know that each molecule doesn't interact heavily with other molecules. One molecule might be going this way, another one might be going this way. They won't even notice each other. That's what makes a covalent molecular substance interesting. Each of its molecules act independently of other molecules. So properties of covalent molecular substances. General properties, not all of them have this, but general ones include low melting and boiling points. So often these substances are fluids at room temperature. And by fluid, I mean gas or liquid. A lot of them are gases. So think oxygen, fluorine, chlorine, nitrogen. But those 4 that I mentioned, oxygen, fluorine, chlorine, and nitrogen, all of them exist as gases at room temperature. And they're all covalent molecular substances as well. You can see they have very low melting and boiling points. They're often non-conductors of electricity. So here you see that on the outside, you've got a covalent molecular substance, and on the inside, you've got a metal. And the covalent molecular substance is an insulator. So it stops electricity from getting out and shocking you. Now, solids that do form are usually soft and waxy. So you could have wax, for instance, is a covalent molecular substance, and they're often soft and easy and very pliable. Now we're going to move on to the other one. There was the covalent molecular ones where you'd have molecules that just kind of drift around by themselves. But now we have covalent network substances. So they're a little bit different. So network structures are all covalently bonded, as we mentioned, because they've got the word covalent there. But the component atoms bond to adjacent atoms to form 3-dimensional lattices of bonded atoms. There's all these words here that I'm throwing around: components, atoms, adjacent, 3-dimensional. But remember, in the covalent molecular, we had just groups together. So little aggregates by themselves. And they didn't want to link together with other ones. They just wanted to be by themselves. Now, in a covalent network substance, you can see that this little guy here will bond to 4 next to it. And those 4 will each bond to 4 more. Each of those will bond to 4 more, etc. So it's very similar to a metallic or an ionic substance, except instead of ionic or metallic bonds, you've got covalent bonds. So you can see that they form this network and lattice structure. Whereas in the molecular case, they would form these groups, and once those groups are formed, there would be no more interaction between any of the atoms. If you were to think about it, network structures each atom interacts with many more atoms than in the covalent molecular case. So this means that individual atoms interact with adjacent atoms very strongly, because you can see there's a very strong covalent bond for adjacent atoms, adjacent meaning next to. For each of the atoms next to whichever atom we're looking at, they interact very heavily because of those very strong covalent bonds. Now, properties of covalent network structures is that they have extremely high melting and boiling point, very, very high melting boiling points. And one example of a covalent network structure is silicon. That's where all our computer chips come from, silicon. They're non-conductors of electricity, or semiconductors sometimes, usually non-conductors. And the exception to this case is graphite. So the stuff in your pencil, it can conduct electricity. Don't go sticking it in a PowerPoint, would be the first thing to tell you. but it's the exception to this rule. So remember that a lot of times there are exceptions. Usually they're very hard, but they're also very brittle. Diamond is the hardest substance known to man. But if I hit it just right, it will shatter, which of course is bad. They are hard, but they're also brittle. Okay, so be aware of that. And in general, they're very insoluble in nearly every substance. There are very few exceptions to this. Okay? So that concludes today's lesson on covalent substances. We looked at covalent molecular and covalent network substances, and we've compared and contrasted how they differ from one another. So we saw that molecular substances exist by themselves, whereas covalent substances like to be linked to every other atom in the crystal or whatever. So I'll move on to the question segment now, and hopefully we'll be able to learn more about these substances.